the way we see the direction of AI heading towards right now, it is leaning in heavily to being centrally controlled by five individual or companies, depending on how you want to view it. And that creates a very strange power dynamic. If you look at OpenAI, for example, they famously said that they generate over 100 billion words per day. And to generate 100 billion words per day, they use 300 plus Azure data centers to cover just 10% of the English market. They haven't fully scaled up to G20. They haven't fully scaled up to the rest of the world. And there's already GPU shortages, rate limits. I'm sure many companies that you know complain about the rate limits and so on and so forth. And that's fundamentally because of how resource hungry the existing transformer architecture is.
Welcome to AI in the Real World. I'm Joanne Chen, a general partner at Foundation Capital. On this show, I speak with leading AI researchers about how cutting-edge models are being used in enterprises today. For this episode, I'm joined by Eugene Cheah, the founder of Recursal. Recursal is working to commercialize RWKV, a new AI architecture that Eugene played a key role in developing. Eugene believes that RWKV can address some of the main limitations of transformers, the technology behind models like GPT and Claude that have fueled the recent AI boom. By combining elements from both transformers and RNNs, RWKV aims to make major improvements in how efficient, scalable, and accessible AI can be. In our discussion, Eugene takes us through his journey from the early days of building RWKV's open source community to launching Recursal to commercializing it. He breaks down how RWKV works, what sets it apart from transformer models, its potential benefits, and its most promising use cases. It was a great conversation, and I think you'll really enjoy it. Eugene, thanks for being here. Let's talk about your personal journey in AI and what sparked your interest in building in this field. Tell us a bit about your story.
I would say that I was dragged into the world of AI rather than there was a bit of intentionality in exploring AI, but I was more like dragged into the world of AI when I was in university. One of the projects that I did was GPU.js. The whole idea was to run JavaScript on the GPU because at that point in time there was the meme of running JavaScript on anything and everything. When we finished that in the 24-hour hackathon, right, we actually managed to get a proof of concept working, which we then subsequently refined and published to the internet. And we managed to get JavaScript to run on GPU, but we realized we couldn't find a specific use case for it. And that's why we didn't commercialize it. But there was one thing that was good at, and that was matrix multiplication. So fast forward a few months since it got released on the internet, it got integrated into Brain.js. And Brain.js at that point in time was the major competitor and alternative to TensorFlow.js. So it was one of the largest library to running AI models in JavaScript. And all of a sudden, overnight, I became tech support to thousands of AI scientists, professors who was using these libraries to run AI models. And that's how I got dragged into the world of AI because my underlying library end up being the backbone for AI models on the internet. And this was pre-transformer era. This is like the neural network, the initial neural network era wave. So that was an interesting experience to say the least. That library is still being used today to generate like anything from generative art to even still being used in courses for neural networks or even AI models. Because one of the benefits of running all these things in the browser was that you do not need to install anything. And even though I originally thought that it wouldn't have much adoption because it's not going to be as fast as CUDA, for example, at the low level, it still remains strong. It still remain strong usage because it's highly useful and scalable when it comes to like in terms of like education, because you do not need the best performance. You just need something that works reliably, and that's where I got my feet started in AI. How I ended up on the current AI wave, be it with the RWKV project. I was searching for an AI model that can handle extremely large context length. And existing transformer models at that point in time could only handle 512 or 1K context length. And I realized very quickly that that if I was to try to scale existing AI models to handle 1 million tokens, because I went to Amazon.com and apparently that was 1 million tokens, uh, I needed something more scalable. And that's how I embarked onto the path of post-transformer AI.
Could you talk about Recursal a little bit and how, what is the mission for the company, and why is this so important, and how does RWKV actually fit in to Recursal?
RWKV is an open source project, right? Which ended up landing on because I was trying to get AI to serve the web essentially. And when I originally joined the project, it wasn't as performant as Transformers, but it promised like extremely low cost inference at potentially infinite context length. And that's what drove me to contribute to the project initially. But over time as I became one of the lead developers involved with it, and now I co-lead this project together with the original creator. The mission have shifted and evolved over time. Right now for the RWKV group, right? Our main mission is to actually make AI accessible to everyone, regardless of language or regardless of economical status. We see the direction that AI is heading towards. And there are two major ones. One is AI, especially within the open source space, tends to lean very heavily towards the English market. And there is understandable reasons why that happens. There has been established research, and we can even confirm this, that if you train an AI model in pure English, it will perform better in English eval compared to training it in multilingual. And you get a 5% give and take performance drop respectively as you add more languages. Because of how hyper competitive evaluations are right now in the AI space, a lot of teams choose to discard multilingual. From our point of view, only less than 20% of the world speaks English, and there is many more people on this earth that will benefit from the access of AI, and we would like to provide them access to it respectively. So that's why the RWKV line of models has over 100 languages supported in it. It's also substantially cheaper to run. We're talking about 10 to 100x, depending on how you deploy it respectively, and can run on rather low end hardware. And this is in line with our second objective as well, to make AI accessible regardless of economical status. Because the way we see the direction of AI heading towards right now, it is leaning in heavily to being centrally controlled by 5 individual or companies, depending on how you want to view it. And that creates a very strange power dynamic, especially if something so powerful, so beneficial for the world is in the control of a handful of individuals. And furthermore, with the way AI is being architected right now, if you look at OpenAI, for example, they famously said that they generate over 100 billion words per day. Uh, and to generate 100 billion words per day, they use 300 plus Azure data centers to cover just 10% of the English market. They haven't fully scaled up to G20. They haven't fully scaled up to the rest of the world. And there's already GPU shortages, rate limits. I'm sure many companies that you know complain about the rate limits and so on and so forth. And that's fundamentally because of how resource hungry the existing transformer architecture is. It is for that reason why Sam Altman was famously quoted saying that he's trying to look into raising $7 trillion in new data center and power plants, essentially. And when I look at all of that, it's like the bottom half of the world is just going to be left out of it. If you look at Indonesia today, they literally cannot afford the 20 USD per month subscription, essentially, because it converts into a large amount in their local currency. We know a lot of people who lives in this side of the world, in those side of the world that will be affected and that will be left out. And we're like, this doesn't make sense. We pursue the goal as well of making AI more scalable, more accessible, and to be able to run on lower end hardware or even more or higher end hardware more cost effectively, so that we can make AI accessible to the rest of the world and in their language. Recursal is simply the commercial entity that is executing on this same vision while commercializing the model for the enterprise to actually fund the development of the open source model while keeping this vision intact. So in a way, you can view us as the truly open AI.
One question on the architecture of RWKV. Could you maybe describe it in a bit more detail? Like, how is this different from standard transformers, and how are you enabling some of the cost savings that you're describing?
One way that I try to frame it, right, is that the way transformer works, right, is that it essentially does decompression on the request that you put in. So for every so to oversimplify it, for every prompt that you put in, if you view every word as a token, what it does is that it converts those tokens into a giant bag of strings of set of numbers. So we're talking about, like, let's say 4,000 floating points respectively, or even 16,000 for some of the larger models. And what it does, and it does unique calculations for every token that you output. You can imagine, as you generate each word effectively, you are redoing all the calculations in your Excel spreadsheet. And then as you generate the next word, you duplicate the entire spreadsheet to just generate the next word. And then you rinse and repeat respectively. So that's why one of the problems faced with transformers is that it has this compounding quadratic scaling cost effectively, because you're constantly duplicating and then changing all the calculations all over again. And this ends up leading into a quadratic cost curve as your context length increase. And this also leads to slowdowns as well, and as you that you may observe when you use ChatGPT, that it tends to slow down, especially when conversation gets longer and longer. On the flip side, right, what we did, right, instead, right, was that we actually took the lessons from the previous generation of AI, which is the RNN architecture, where it maintains a state in between tokens, and this maintains a fixed state, respectively. So instead of redoing all the calculations behind the scene for every token being generated, we get to reuse the previous calculations, and then we save it within a state. And how we save it within the state is that the reason why RNNs previously didn't work out as well uh, was that essentially that the way it was designed was based around a module called LSTM, and that was highly inefficient because of the way data was flowing. We replaced that building block with the same building blocks that Transformer use. We're talking about matrix multiplication and pseudo activation functions and things like that. And essentially, what we use is the same basic building block that Transformer use to update these states and maintain it between each token. And by doing so, we're able to create an architecture that is highly scalable, like a transformer in training, but it's also highly scalable, like an RNN in inference. And this allows us to have a linear computational cost compared to a quadratic cost, and that makes us much more scalable, respectively. And particularly for VCs, I think they can understand the difference between quadratic versus linear cost.
Yes, that makes a lot of sense, and thank you for explaining that. When you think about the performance today, could you give a bit of perspective on the differences as it stands today?
We realized that Transformers essentially as an architecture hasn't changed much in the past 6 years plus. It has always just been scaling more and more tokens and parameters. And I think the aha moment for us was that when Eloter AI helped wrote our paper regarding our architecture, they realized that we have caught up with essentially GPT-3 and GPT-2. And we start realizing that because we were already preparing for the next generation of architecture, that there is some signs and promise that it actually scales better than transformers. This is very hard to say conclusively because we have absolutely no idea about what's the data set everyone used. It can be exemplified in our very recent 1.7 trillion token 7B model. We train it on 1.7 trillion token, and we managed to match Llama 2 2 trillion token model in terms of English evaluations. And we were able to outperform it, all 7B models across 100 plus languages in non-English evaluations. So, so we already saw early signs that it might be more scalable than Transformers, but as we were scaling it upwards to 7 billion and 1.7 trillion token, we realized that it might actually be even more scalable. Whether this is a direct apple to apple is non-conclusive because we do not have access to Facebook data. It could very well just be the data was the problem. It'll be funny if, let's say, a team of random folks from the internet managed to build a better data set than a multi-billion dollar enterprise with a multi-million dollar team that built the data set.
Hey, this is the beauty of startups. Startups are moving faster and are more nimble, so lots of things can definitely be achieved. One of the questions around use cases I wanted to ask: what are the use cases, especially new use cases, that this is unlocking?
What I particularly love these days, right, is to see AI being deployed in non-chat and non-RAG use cases. AI being deployed as part of the processes within a company. Because sometimes it's the small little things that you can scale up to like a million or a billion times per day that actually has a huge impact respectively. So for example, right, for one of the companies that we work closely with, right, they are using our AI model to do content moderation at scale. And what they essentially sell to parents is a product that promises that all messages are safe for kids, essentially. And and they process approximately more than 5 million messages per day. They wanted an AI model that can scale with them, because if they're using, let's say, the best and the largest model, they're looking at an AI build that's tens of millions of dollars a month. But for us, right, because we are much more scalable architecture, they are looking at sub 10, 100K build for to be able to actually do all this kind of analysis on the messages of whether is this message safe for my kid. And what's particularly exciting for me is that we get to see these things work at scale essentially. Another reason was that they actually did try other 7 billion parameter language models, and one of the issues that they face is apparently kids bully each other in America in languages other than English. People insult and bully each other in languages beyond English, and and that's what our model is able to support and shine through, because it's able to understand all these nuances in multiple languages. One of the rules that we run internally is only a native speaker can judge whether the data set or the model's performance in the language is better or worse, respectively. No one else. And the reason why we say this is that there are actually existing models that is made in Silicon Valley that was trained on multilingual data, but they were using essentially Google translated multilingual data. And then when we asked native speakers why, what was their experience with it, and it's like, it just sucks. That's not how that's not the correct way to use our language. And it's like, yeah, okay, that makes sense because the training data was machine translated, so it's like garbage in garbage out situation. For all these high volume use cases, right, it's not about the biggest or best model on earth. It's about having that one model that's adjusted for their use case, but they can run it at scale. And that is sometimes some of the most high impact use cases that you won't hear people screaming on the rooftop that it's run by AI.
To play devil's advocate just for a minute, one argument could be that, hey, if we have more compute power and more data, let's say we don't have the same GPU constraint as today, um, do the different architectures matter as much? Or if the compute power cost goes down, which is what a lot of our companies are trying to work on as well, how do you see that play out?
So I think another way to frame the question is like, does the architecture matter if, let's say, they all perform similarly in terms of performance given the same data? Then if you view it from a purely I get a result for my request, there's an argument to make that it doesn't matter. But I can flip the question around as well. If it doesn't matter, if the quality matches, and to the end user it doesn't matter, and one is literally 100x cheaper, why should we ignore it? a lot of these existing AI provider does really well is that they abstract away the cost of AI. In many cases, and I'm well aware for a lot of providers, and even OpenAI itself is reportedly, they are still making losses in trying to deliver AI. So this is not a sustainable situation. We haven't reached a sustainable stage yet. Many providers are actually bleeding just to make AI work. And and when a lot of folks think about AI, they just think about, hey, it's just running on a single server. And then I'm like, do you know how much resources it takes to compute a single request today? Right now, for ChatGPT, in the filing to the US government, they actually stated that it took over 12 iPhone charge and discharge cycles to answer one question in ChatGPT. And these AI models are running on hardware, right? That is exceeds 300K just to answer one question for one user at a point in time. And and so when enterprises are looking into deploying these things within your environment, right? There'll be so many times where they get shocked about, hey, why is the projected bill, right, more expensive than my entire company itself? and 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 the thing is that you don't get to feel that because you've been making requests and then you pay by the token, because all this scaling and deployment complexity is abstracted away from you. But and in some cases it's also subsidized away from you. But at the end of the day, right, market forces will arrive into where it makes sense. These companies cannot perpetually lose money to sustain their business, because that's not business. And subsequently, enterprises who want to be able to deploy their own set of AI models will require the resources, will explore architectures that are more efficient. And we already see that enterprises are actually exploring smaller size AI models in their own specific use cases, or architecture that's more specific to their use case, because if you put it into perspective, like the sheer amount of resources required to deploy, let's say, a 400B model, we are talking about an entire rack worth of GPU that costs at least close to 5 million up. And this, you don't want to spend. The worst case scenario is you deploy one of these and your employee asks, "Oh, tell me a fun joke about a fun dad joke." You don't want to spend $5 million to answer funny dad jokes, essentially. And that's why it's always about, eventually we'll arrive at the point where it's about meeting the performance target at the specific price point. And if you want to see a direct parallel, look at the database era. We started at, we don't care about cost and performance, be them. Cost be them, get the best performance possible. And then eventually what we realized is that, hey, this doesn't make sense. And we started layering our architecture. So that's why in the database world, you have SQLs, you have your analytics database systems for all those more complex analytics, respectively. And you have providers like Redis, all those key value cache providers. And the last one is just to make sure that things can scale in an affordable manner. And you look at the top Fortune 1000 websites and so on, a large percentage of them, right? A large percentage of them use the key value databases as their running worker to actually handle the bulk of their requests. And when they needed those more complex analytics, they use the more expensive SQL or their analytics databases to do the more expensive requests, respectively. And this is just so that they can make their websites more scalable. And you go to any social media website, they do a similar thing as well. It's all about like making things make sense at scale. And and right now it's being abstracted away, but eventually we will need to face it again.
Some of the benchmarks that you were alluding to, from your standpoint, how do you think about these benchmarks in the next 12 months or 18 months and 24 months in terms of what your goals are? And then I think the other question I had, is, there's a lot of effort on multimodal, right? I mean, OpenAI just launched a pretty impressive set of multimodal models. Curious how you're thinking about that world as well.
our current immediate plan, right, is that because we see that the enterprise market is extremely hungry to be able to control AI and run it within the environment. So our most immediate roadmap is actually to scale up to GPT 3.5 and GPT 4 class and deploy in their environment respectively. Then subsequently is to add multimodal support when it comes to audio and vision recognition. And from an architecture standpoint, right, it's actually no different from what you see for existing transformers. Our architecture at the end of the day, right, um, uh, is still token slash embedding in architecture and an embedding out architecture, which is the same as transformers. And we already have existing smaller models that has been used for music generation, audio generation, even image generation, and likewise vision recognition and audio recognition as well. And so from an architecture standpoint, right, it's all about just converting these multimodal sources into the respective embedding to feed into the model. And and that becomes more of like a scaling and training question respectively. So that's part of the reason why we set up the commercial arm to actually scale the the company to make this commercially viable, to actually start deploying it inside the customers' environments. And we have early customers that are actually really excited about deploying us. We want to take the approach that similar to like some of the database company, where we start going in commercially, get those revenue in, use that revenue to make a better model, and then using a better model, unlock new market segments, and get more revenue in, and basically hence constantly looping the process of where we have more business and more customers that helps fund the development of better models that help us get more business and more customers, and then loop accordingly, hence recursal. And that's the way I view it respectively.
That's very helpful. Prompt engineering was really crucial for some of the strong performance. And just curious, how do you think about prompt design, and why is this so important? This is just an aside, as part of our earlier conversation.
I think one of the shifts that within our architecture is that because it maintains memories, right? And I will even allude that this is like similar to how humans work, right? Is that it helps significantly if you are extremely upfront in what you are trying to ask it for. In our latest architecture, for most parts, if your request is under 8K tokens, and when we scale up under 80K tokens, the prompt engineering issues are actually mostly mitigated due to some things that we have added. But then, if let's say you want to go beyond that, essentially what you have to recognize is that transformers, the way they work, right, is that because and part of the reason why they have that scaling cost, right, is that they never let go of anything. They make multiple duplicates of every single piece of data, and essentially that explodes exponentially as the more you converse to it. On the flip side, we compress all this data into a fixed state, but that means the model also makes a decision on what to compress and what to let go.
There's still a number of technical hurdles, right? What are the things you're most excited about working on, in the next 12 months?
Actually, I wouldn't say is technical hurdles. Actually, the biggest hurdle right now is actually more of a scaling and funding hurdle, respectively, or resource hurdle. And that's part of the reason why we are fundraising as well. And because we have already tested our architecture to work all the way until 60B, 70B param size approximately. And all of this we are still retaining the benefits of our highly scalable architecture. And the thing is, the open source market has already shown that 70B is pretty much all you need for GPT-4 class. So I think right now, right, the market is hungry enough for a GPT-4 class model that we don't really need to build a 500 billion parameter model, because once again, like, most of my customers don't even want to run that in their environment. So so the common pushback that we face is that there's the argument to be made that, hey, we didn't spend that $10 million training run like NVIDIA did. Historically, what really unlocked one of the things that really unlocked the large scale training was that NVIDIA and Google essentially sponsored, here is your 10 trillion parameter transformer model, and this is the loss curve for the first few chunks. And that proved to folks like OpenAI and the rest of the world that hey, this is an architecture that's scaled to 10 trillion parameters and so on. And therefore that has always been framed as hey, you have never scaled the 10 trillion parameters. You can't prove that it works there. And then my response right now is, do I need to? My customers are not asking for it. And well, we will still push the boundaries of scaling our model. We are in works with actually one of the supercomputer clusters to potentially run a 500 billion parameter training run to test the architecture to its limits as well. I think that all those are less of a technical hurdle and more of like a scaling and resource hurdle. Likewise, I also mentioned that we have already validated that the architecture works with vision and audio recognition and vision and audio output. And just now a function of like getting the resources, getting the data sets, and then deploying it respectively to train and scale this model. And if everything all falls into place, we are going to look at a very dramatic 100x drop in AI pricing that is completely runnable on Recursal, essentially, that everyone has access to. And then this will unlock like AI agents, AI use cases at a new scale altogether. And that's why I still like to think beyond chat, because AI agents, like every time you trigger an AI agent, it's not uncommon for it to like do 10 requests behind the scene or even 100 requests. We're already starting to see AI agents where you give it a task and then it runs for like 20 hours doing millions of requests behind the scene to get one job done. And those are like the kind of like scale when it comes to AI that I am more interested in.
How about if you look even more ahead, 2 to 3 years? What are some of the uh, most promising research areas in general for AI architectures? What are you seeing today? And this is beyond kind of the work that you're doing at Recurso and RWKV.
I think there are two major segments. One is dataset. I think one of the things that I'm very excited about is that because there's a strong narrative being pushed by the large major AI organizations that there's not enough tokens in the world to train AI models. And but that has already been shown to be false, because it's more of like a case of there's not enough tokens that people are willing to pay to digitize. Essentially, there's actually like if you look at US alone, court documents and papers being published, right, that is over 1 trillion token per year, and you just need to backdate accordingly. But the problem is once you start backdating, a lot of this data is in images, not text. So it becomes a conversion process issue. And sure, we have OCR, and OCR is making leaps and bounds, and it's getting better and better. But the problem is, even our best OCR right now requires a human to review and intervene and make corrections. And well, we are starting to use AI to help automate the process, right? It still requires some form of human in the loop, essentially. And so the issue has always been more of like scaling up this process. And the thing is, what was exciting was to see the open source community rally and scale these processes respectively. Like if you ask a lot of researchers previously, they thought that there might not be enough tokens in the open source space, and we may not be able to match, let's say, Facebook, etc. But when Facebook announced 15 trillion tokens, subsequently the folks at Hugging Face and from various groups, they said, yep, here's 15 trillion tokens of data that we collected together and we were preparing behind the scene. Pop. Here is now anyone can train on it. So this kind of like removes the barriers when it comes to like data set. Like and the thing is, like, for us, because we work with multiple teams in collaboration, we're actually seeing these data sets being built before they come out into public, like especially for some of the multilingual ones. And we see momentum. We see more and more work being done, because for some countries and some languages, they don't want their languages to be left behind. And so when it comes to like token scarcity, right? We are people ask me like, is there a shortage of tokens? I think at our current stage, right, we don't even have enough compute to eat all the tokens that we have. So it's more of a case of there isn't really a token scarcity these days anymore, especially if you are being mindful of how you train stuff. And as we all know, like the more tokens you feed a model, it gets better. So that's one thing that's exciting. When it comes to architecture, um, actually, one thing that I'm really happy about is that now with the rise of bit RWKV, state space, XLSTM, like all these new alternatives, people are starting to take alternatives much more seriously. And there's so much research into architecture design that could have actually very huge long tail impact. For example, I have a standing statement of saying I want people to work on diffusion text models, and you can find this in like some of my past interviews as well. I may not be on team text diffusion, but I actually was excited to see more research being done on it because what like one of the things that for example all existing AI models and architecture do not perform well in, that includes RWKV, that includes transformers, is that we tend to have a negative penalty when we train on the same set of tokens too many times. If you repeat it too many times, the model degrades in performance. But there is one architecture that seems to be immune to this, and that is the image diffusion models. The image diffusion models are commonly trained like 600 or even 1,000 times over the dataset, and they still improve in performance and not degrade respectively. And we do not know why. So that's why I'm actually excited to see like research into this area, because my question is more of like, how do we unlock that why and how? And that might actually end up cascading. And for all we know, it's just something very simple that we can then cascade over to our architecture and even maybe the transformer architecture.
If folks want to learn more about different um, architectures, right, post transformers, curious where are there resources, podcasts, stuff that they could read that you recommend?
I recommend be it our Discord community or wiki.rlkv.com, and that would be the early starting point. And then you start exploring into that respectively. Um, Other major Discord group that I'll shout out, it'll be like the Illuter AI Discord group. Illuter AI is a research non-profit group that is primarily oriented to democratizing AI, and they literally experiment and train in all architectures. They do publish a lot of papers, and their community is very active into teaching and sharing and learning from each other. So yeah, if you want to like hear from the latest of research into like the newer architecture, right? That's one group respectively that is not siloed in.
Great. Thank you so much, Eugene.